Hello, my name is Minh Ha-Duong. I am from CIRED CNRS, and my co-author Nguyen is from National Economic University in Hanoi. Today we will present research on electricity poverty in Vietnam. What is electricity poverty? We think electricity poverty is when people say no to the question, in the last month, did the consumption of electricity meet the need of your households? So yes, we as engineers, as economists, have other angles to measure energy poverty. We measure access to reliable electricity. That's how much the grid reach into the village. We measure the satisfaction of basic needs. We measure the share of households that are below energy poverty line. We even have a multidimensional index of energy poverty. But all this is interesting and sophisticated econometrics. But maybe it's simpler to just ask for people if their energy use met their needs, and have a yes or no question. Our data we used is the Vietnam Household Living Standard Survey from 2008 to 2018. And in this survey, they ask questions about what do you use for lighting, which can be used as a proxy to measure access to the grid. The survey asks about electricity bill and about income, and the survey asks if electricity use meet their needs. So this Vietnam Household Living Standard Survey allows to study electricity poverty from the three engineering, economists, and social angle. First, from the engineering point of view, we learned that quasi-universal access was achieved a long time ago in Vietnam. So Vietnam is a very successful country in terms of electrification. In this country, in this graph, the more yellow, the more electrified is the province. And you can see in 2008 there were only a few provinces in the mountain in the north that remained to be electrified. And progress is slow, but nowadays more than 99% of the households have access to a grid. Second point of view, economics. Economics is simplified, do you pay a lot for your electricity compared to your income? And we see that in Vietnam, electricity is cheap for households, and it's even cheaper for industry. The 80% of households spend less than 4% of their income of electricity. So people really have a small electricity bill. And even in 2008, the electricity bill was even smaller. So you could think that in 2008, the engineering point of view said there was access, the electricity bill was very cheap, maybe people were happy. But in fact, if we look at the third point of view, no, in 2008, 2010, people did not have enough electricity to meet their needs. That's what this map shows. The survey shows that the more red, the more unsatisfied are the needs of the people. And so what we learn from the social point of view is different from what we learned from the engineering and economic point of view. Yes, there was access. Yes, it was cheap, but in fact the demand was not satisfied. There was restriction and like only 8 hours of electricity per day over the country. So it's only after 2010 that the electricity improved. That way we show that there are three different kind of electricity poverty criteria. In the pink one, we represent electricity users that use less than 1 kilowatt-hour per day. So probably basic needs are not met. You cannot use a fridge, not even a TV. So basic needs are not met in pink, and the one who declare that their needs are not met in green, and you see the two criteria do not overlap. And the third economic criteria is even more different. So I conclude that electricity poverty is a human issue. It's not just engineering and economic problems. You can measure it simply by asking people if electricity use met their needs, and the answer is interesting and show things that we didn't see. So maybe that could be applied to sustainable development goal indicators that are all about engineering and economics and nothing about subjective, only two. Thank you, and the working paper is here.
Hello everyone, my name is Yermone Sargsyan and I'm a PhD candidate at Haas University. My research is about the impact of electricity outages on health outcomes of the children in Kyrgyz Republic. In many countries in the developing world, we still have to deal with the lack of the access to reliable energy source due to the outages, poor infrastructure, or high prices. In this research, we actually observe some negative and statistically significant relationship between access to electricity, the frequency of outages, and the health outcomes of the children. So empirical study usually identifies several pathways at which electricity may affect our health. First of all, electricity is a source of cooking, heating, which may decrease the respiratory diseases. And also, of course, electricity is facilitating the refrigeration, boiling of water, which is also reducing the infectional diseases. In our research, we focus more on children from 0 to 5 years. As a health outcome proxy, we use anthropometric outcomes like height for age, weight for age, suggested by World Health Organization and calculated as a deviation from the given reference group. Relationship between electricity and household attributes, social economic attributes like income, education, health is well documented on the literature, but literature usually identify the relationship between just access to the grid as a binary variable, whereas in our research, we try to understand how the frequency of outages affecting the health outcome of the children. For this research, we employ household level panel data from Kyrgyzstan. The data collection has been administered by ITSA, International Data Service Center. Here you can see on the figure the electricity disruption in all regions of Kyrgyzstan. In our data, we have 7 self-reported categories for the outages. It is no power supply at all, never, every day, several times a week, once a month, and several times a year. So from graph, you can see that it is quite regular phenomenon in the country to have outages. And outages are different from dwelling to dwelling, even if they are located in the same neighborhood. Here you can see our summary statistics. The important part here to notice is that electricity disruption once a month is near 20%, and more than once a month, which is once a week, several times a week, or every day is, again, overall near 20%. And here we have height for age Z-score and weight for age Z-score, the mean. So overall in our sample, near 7% of the children are considered to be overweight, and more than 70% of children are considered to be stunted. According to World Health Organization, stunted results in delay mental development, poor school performance, and reduced intellectual capacity. So this is really important to notice. This is our empirical model. Here you can see height for age and weight for age, Z-score, as a proxy for the health outcome. We control for the income. This is household income in USD. We control for the food expenditure of the household, again in USD. Household labor stands for number of working age adults in the household. Age is the age of the child in months. And of course, we control for the household and year fixed effect. So outages here is just dummy variable, which indicates the disruption in electricity more than once a month. We divide our sample into two income groups, and we run our regression for full sample and for the lowest 50 percentile. So for the full sample, we don't observe any statistical significant relationship. For the lowest 50%, we see that electricity disruption more than once a month affect height of the children negatively. And this indicates that people with relatively smaller income are more vulnerable towards the electricity disruption. We also control for income, but it is not statistically significant, I guess, because we have some noise in our data. That's why we use food expenditure and a number of working age adults in the household as a proxy for the income. And we see that they are significant here. So the main message of this research is that electricity supply reliability is vital for the child development, and frequent outages negatively affecting the human capital, which in turn affect the economic productivity at national level. So thank you very much, and I am looking forward to your questions.
Hello, my name is Luca Casamassima, and I'm going to introduce you to the work I've been doing with some of my colleagues called Positive Energy Districts, a critical review of definition and characteristics. So first of all, for the research questions, and how do positive energy districts stand out from other similar concepts that we've seen in the past, such as net zero energy communities or net zero energy neighborhoods, for example? And how have these concepts been evolving regarding energy efficiency, and what are the common barriers and facilitators that we've already seen happening with these concepts, and maybe we can avoid the barriers and replicate the facilitators that we've seen in the past already. And first of all, the methodology had to be done and developed. We divided the analysis in 6 parts: the energy balance, the environment, the energy efficiency, the techno-economics analysis, the spatial aspects, and the social aspects. And to do so, we have done a literature review based on peer-reviewed paper and grey literature. The grey literature was included because a lot of these documents started through grey literature, non-peer-reviewed paper, but nonetheless, we analyzed around 70 documents. Starting from the history, we see that passive solar gain design was the first choice that started during the oil crisis of the 70s, and with time this passive solar design was actually substituted by super insulation, a concept that the Passive House Foundation would embrace completely together with a mechanical and controlled ventilation. As time goes by, we see also the rise of net zero energy building and nearly zero energy building. But by the end of the year 2000 and the beginning of 2010, there is a new approach to designing buildings, which is designing neighborhoods in its entirety and accounting in a more holistic manner the energy flows and the energy needs of the population in that districts. And that's how positive energy districts actually came to be. And initially, JPI only gave a very large definition, a very easy definition, which only said that net positive energy balance must be respected, must be energy efficient, must have energy flexibility, and must ensure just transition for this green transition that we need to have for the future. And of course, this was left very open, mainly because we have so many different cultures in Europe and so many different climates that it would be too restricting to have one unique definition for example, necessary energy savings. And this is where research and projects all around have been filling the gaps that have been left open without being too restrictive to be hindering actually the development. And for the energy balance, we have primary energy is being decided that needs to be accounted. Positive over the year, of course, it's a basic requirement, and it must include public services such as light in the streets or public transportation. For the environment, we have net zero greenhouse gases, but there isn't for now any mandatory that tells us to account for particulate matter, SOx or NOx. We've seen it in some projects, the SOx or NOx, but they're not mandatory for now. For the energy efficiency, we see all over the research that building retrofits and increasing their energy efficiency is very important. It's always been repeated. Life cycle assessment of CO2, of course, and Making Cities actually has developed a framework for developers in cities to aid and decide what are the parts that need more tackling a little bit more the energy issue, for example. For the economic aspects, we have the maximization of cost effectiveness. It's been there is no real suggestion on what methodology to use. Cost benefit analysis and net present value have some that have been seen a little bit more around. For the spatial aspects, we have nuclear boundaries, and that's to facilitate in some other places where, for example, a neighborhood, a district might be 100,000 people, and some other cities are in total 100,000 people. So setting a very definitive way of defining boundaries may be hindering. And then we have that the boundaries have been divided into autonomous, dynamic, and virtual, meaning that the autonomous can only exchange in one direction. It can only export energy, but it can't import energy, and it must produce everything inside. Dynamic instead can import and export energy, so it doesn't need a constant positive energy balance, and it can import. And virtual have some of the assets for producing energy outside of the boundaries, meaning that's why it's called virtually, they're not inside. For the social aspects, we have that energy poverty and energy justice are a cornerstone of positive energy districts, and local participation and participation of marginalized group might be a very good way to do this, although it's not mandated for now. Distributed benefits and burdens are kind of a natural part of renewable energy sources as they are distributed, and that might also facilitate a little bit of the social aspects. This is a page with all the references from the previous page, and thank you for your attention. I hope you enjoyed the presentation.
On one hand, 70% of the primary energy use in the European Union is urban, and approximately 90% of the energy increase globally is in cities. On the other hand, only a fraction of the energy is actually generated in urban areas, and if it is, it's hardly renewable. Additionally, approximately 75% of the global CO2 emissions are coming from cities. So this requires a massive transformation of urban areas from only demanding energy to also contributing to clean energy generation and distribution. This is where my research about positive energy districts will come into play, where I'm currently working on the different potentials across Europe. Thus, today I will present you my research in progress concerning this topic. Positive energy districts are a concept that has been created by the European Commission in order to address urban CO2 pollution. As you can see in this little figure that I created, the two major constraints of a positive energy district are to have a positive energy balance created by locally generated renewable excess energy, as well as being CO2 neutral, as I illustrated there. Additionally, flexibility and grid stability should also be focused on. The aim of the European Commission, therefore, is to have 100 PDs in planning, development, or operation by 2025. This brings me straight to my current research question. As we all know, the European Union is very diverse in terms of climatic conditions, electricity demand and electricity grid mixes locally, heating and cooling demand, and finally also behavior. And all of this will affect where the PD might have its highest potential in terms of primary energy demand or savings, CO2 emission reduction potential, or economic feasibility. So this is why my current research question is, where does the PED concept has its highest potential across the European Union, and why? In order to approach that question, I developed a tailor-made mixed interlinear programming model in Python using Pyomo for the analysis of multi-energy positive energy districts, and the core of the model is the primary energy balance. The model takes a variety of input data, such as technology-related data, such as cost, efficiency, and technology selection, empirical time series data, such as load or irradiance, emission and fuel data, and finally also location-specific data, such as roof space available. The output of the model is the most relevant outputs, at least, are created are the general feasibility due to space restriction, as I mentioned before, of the positive energy district, the net present value, and its cost composition, and the energy dispatch. In order to feed the model, I will then cluster Europe in 10 to 15 sites according to the aforementioned indicators. I will have access to a multi-energy synthetic demand profile for a specific site in Germany. And then I will use this time series data to teach a machine learning model, most likely a random forest model, on certain variables such as outer temperature or solar radiance. And this model will then be used to create demand series for all predefined areas to achieve a most representative input data for the European Union. As I did not obtain the synthetic load profiles yet, I will show you the results of a study I did for the Canary Islands that has an electricity demand only due to its favorable climatic conditions. Here you can see the net present value composition by scenario, and you can see that the status quo scenario, which is basically only electricity bought from the grid, has a net present value about 100,000 euros lower than the PED scenario, even though the PED scenario has a lot of investment cost of PV. However, if we look on the distribution of the grid exchange power observations, you can also see that the export power here in green has a very high values compared to the import power. So if we limit the export power to about, so in this case, 1.5 times the highest demand at a certain time step, we can see that batteries are enforced to be bought, and therefore the investment cost increases drastically, and therefore the PED is not financially feasible anymore in 20 years. Here you can also see the primary energy demand over 20 years of the project. So in case you want to develop one of the 100 PEDs and you're not quite sure where to place it yet, stay tuned on how my research is gonna pan out, and connect with me on LinkedIn or ResearchGate for more questions or any news about my research. Also, I'm super happy for any suggestions or criticism. Thanks a lot, and see you soon. Bye.
Hello, everybody, and welcome to my poster presentation on demand responsive transport services. My name is Schasché, and I'm currently employed at the University of Klagenfurt in Austria, working on integrated mobility solutions for rural regions. I will now present selected results of my systematic literature review on that topic and some of the discussion points and practical implications. Climate change is in everybody's mind nowadays, and the transport sector counts responsible for about a quarter of all carbon emissions worldwide, and it needs to find solutions for that. For passenger transport and individual transport, the increase of public transport is viewed as a vital contributor. In the EU, 29% of citizens live in rural areas, though, where the provision of classic public transport is rather inefficient and financially unfeasible. Demand responsive transport is positioned as a solution for the outlined situation. DRT, as I will call this form of public transport, from now on, is loosely defined as an intermediate service reacting on user demand and not bound to set times or courses. It utilizes mostly small floor buses, as you can see on my poster here. But although trial projects are installed and quite an effort is made to establish DRT services, most of them face substantial problems such as financing issues or too little demand. Against this backdrop, the systematic literature review that I present summarizes previous research on DRT with a focus on users on the social scientific approach. 231 articles were analyzed and categorized according to the research field, and 44 articles with a social scientific approach underwent a thorough content analysis. User focus deserves a deeper exploration, considering that all efforts will fail without people accepting DRT services as a satisfying offer for them. Now, the history and development of DRT services are heterogeneous, but scientific attention is rising as of late, as you can see on the top right corner of my poster. Also visible there is that research on users holds the smallest share, even though it's vital for the success of the service. Another finding of the conducted content analysis is that DRT is expected to excel in 3 dimensions. Besides a strong historically grown focus on social benefits, they're recently expected to contribute ecologically. Furthermore, DRT services are expected to operate cost covering and reduce the necessary funding of public transport. Consequently, Elkington's triple bottom line is naturally suitable as a structuring concept for the evaluation of DRT services. And also, the outlined threefold expectation is conflicting, posing a possible explanation for the previous failure of DRT services. Therefore, further research should definitely address this conflict. The analysis of factors influencing user acceptance of DRT services that were identified in the 44 articles does not come to conclusive results. A reason for that might be found in the strongly differing design of empiric studies. While some of them focus on actual users, others target groups such as elderly people or commuters. Furthermore, various approaches to the exploration of user acceptance are taken, with few of them grounding on a theoretical framework. Further research could therefore establish a common pool of factors for future use in empiric studies in order to produce comparable data. Practical implications include the suggestion to establish a holistic business reporting that discloses social and ecological value that is created by DRT services. Services should further decide on which dimension to target and then subsequently address the according target group. A targeted information provision and marketing initiatives that enable first tryouts and create positive experiences with DRT services would also help to enhance user acceptance. Now, in this literature review, I identified a significant influence of population density of the serviced areas on the expectations towards the service, on the potential users, and on other aspects. Therefore, I believe that a conscious distinction between urban and rural settings will result in more transferability of conducted research and in a clearer vision for DRT in general. Now, other results and more details can be found on the website on my poster. I plan to submit the article for publication soon, and in case you're interested in it or happen to have any other questions, please feel free to contact me. I'm looking forward to it. Now, thanks very much for listening. Have a great day and goodbye.
For an airline, the Paris Agreement seems like a threat to its very existence. But can it also be an opportunity? With this question, I would like to welcome you to my short presentation about my master thesis, which dealt exactly with this issue. In tackling climate change, aviation sector plays a crucial role. Globally, the sector accounts for roughly 2% of emissions, but this low figure is mainly due to the fact that only a small part of the world's population flies. If we just look at Switzerland, for example, we see that 19% of the country's emissions are due to flying. Also, strong growth in demand for flying is predicted, especially in Asia. And it is not a sector we can simply walk away from. At the same time, airlines are under pressure to mitigate their emissions drastically. In my thesis, I took the strategic perspective of airlines and addressed exactly these challenges. The ultimate goal of the thesis was to develop strategies to become a truly sustainable airline. I would like to point out that I focused only on environmental sustainability and that my research was conducted just before the COVID pandemic hit, so I unfortunately could not include its implications in my research. As a starting point, I needed to define what the goal was, so what it means for an airline to be truly sustainable. On the basis of IPCC reports, I defined full environmental sustainability for airlines as compliance with the Paris Agreement. This translates into two requirements. For one, no use of fossil resources, and secondly, no use of net zero greenhouse gas emissions by 2050. Another basis for the analysis was this framework, which categorizes sustainability approaches into efficiency, sufficiency, and consistency. With efficiency, emissions are reduced by incremental change and continuous improvement of operations and technology. Sufficiency means to consume less, which in this case means to reduce the number of flights. And consistency means to replace current flight technologies, so engines and fuels, with completely new technologies which are much more sustainable. The empirical analysis itself was a qualitative case study design which involved 11 semi-structured interviews from experts with various organizations, and also desk research was conducted to complement or cross-check the primary data of the interviews. The main finding of evaluating Swiss's current sustainability strategy was that it is a step in the right direction, but by far not drastic enough. So far, most of the progress was achieved with efficiency measures, but these bear little further potential. The largest potential for reducing emissions is consistency, so to switch to another technology. But the solution is not electric or hydrogen aircrafts, since there are still many operational and technological barriers to overcome. Instead, synthetic fuels are seen as the solution. Here, carbon is captured from the air and with solar energy transformed into liquid fuel. First functioning device producing synth fuels is standing in Zurich already. Here on the slide, you also see a picture from it. The current main problem with synthetic fuels are financing and availability. Production sites are only starting to be built, and additional support, especially from policy, is needed to commercialize synth fuels. Concerning sufficiency, it is important to decrease the amount of especially short-haul flights and replace them by, for example, high-speed trains. Technological progress in this area is really immense, and customers also show an increased tendency to switch to rail. Barriers here are the international collaboration needed and the large amount of infrastructure to be built or improved. With these insights, I developed two scenarios and strategy recommendations for Swiss, which you see, the first one you see here. The first scenario is called Green Status Quo, which is a rather pessimistic scenario concerning environmental action. On the right here, you see the corresponding strategy, Haas, which provides an overview of the environmental developments, then the capabilities Swiss has, and then also that it needs to build, then the concrete measures to be taken, and finally the vision of the strategy. The advice here is really to focus on the commercialization of synthetic fuels and eventually also integrate backwards and diversify into becoming a synthetic fuel producer. In the second scenario, this is called the multimodal mobility scenario. Synthetic fuels here already receive a lot of support from policy and the industry, so Swiss can instead focus on sufficiency. Together with other airlines and rail companies, they built an international multimodal platform following the mobility as a service approach, and short-haul flights are slowly phased out and replaced by high-speed rail. So my personal recommendation for you is to compensate your next flight with sustainable fuel. And I would also like to point out that together with the Institute, we are publishing a book including several perspectives on sustainable aviation. So if you're in the coming months, so if you want to learn more, I really recommend this book. And also, if you have questions, you can reach out to me via LinkedIn or email. And with that, I thank you for your attention and look forward to your questions.